Hello, this is John from caveofprogramming.com, and in this tutorial I'm going to create a sprite class, and I'm going to aim to actually draw something on the screen using that sprite class. And just in case you're not a games programmer, a sprite is the idea of a sprite is a sprite is something that represents something visually on the screen, and sprites can have some kind of animation in them, which I'm not going to animate the actual sprite itself here. I'm going to move things around the screen, but I'm not going to use different bitmaps to represent a sprite in different states. So a sprite could represent someone walking on the screen, and then you'd have different bitmaps for each phase of the walk. And I'm not going to do that here, but what I am going to do is I'm going to have a sprite class that I'm going to use to create my game objects, which is going to be two bats and a ball in this case. And that's going to handle drawing itself on the screen and remembering its own position. So let's right click here and go to new class, and I'll call this sprite. And I'm not intending to use this, I'm going to use child classes of this sprite, but for the moment I'll use this class itself just to get something visually working that we can actually see. And I'll add to this sprite as I go along, but at the minimum it's going to have a public float x and a public float y. And let's give it a constructor like public sprite, and we could give it maybe an initial position, float x and float y. And you might wonder why, given that positions on the screen are going to ultimately be integer values. Why are we using float for x and y? And the answer is that we might want to add a speed to x and to y, and when we render the sprite, we have to align it with a pixel boundary, so we have to translate these into integer values. But to keep the animation as smooth as possible, we might nevertheless want to remember the float position, so we remember where the sprite should be precisely, but when we render it we have to move it to the nearest pixel in effect. So I'm going to use float for x and y for greater accuracy. And a sprite needs to be able to draw itself, of course, so let's say public void draw, and in order to draw itself it's going to have to be passed a canvas to draw on. So I'm going to make the draw method accept a canvas. Let's add the input for that, and the sprite will have to update itself as well. So let's say public void update, and in order to update itself it's gonna need some information, and well, it's definitely going to need the amount of time that passed since the update was last called. And I probably want to pass it. I probably want to pass it the width and height of the screen, because it's going to have to know what the width and height of the screen is. So let's probably pass that in here. Or another alternative is we could supply it, let's say, to the constructor, which would also work. We can't supply the canvas to the constructor because every time we draw we're going to lock the surface holder and get a new canvas, so this is going to be different every time, and the kind of width and height of the screen presumably will remain fixed. So if we're not too worried about the user resizing the screen, then potentially we could just pass it to the constructor, which I'm quite tempted by that idea actually. So I think I'll say int width and int, let's call it screen width, and screen height. And I'm not even sure really about passing in an initial value for x and y, because probably we could figure that out. Yeah, let's scrap that. I'm kind of thinking on my feet slightly. Let's just initially hard code values for that. But what I will do is I will have here, that should be private of course, I will have the width and height of the screen here. So let's say private int screen, and this needs to be consistent as well, screen width, screen height, screen width, and private int screen height. And then let's say down here that this dot screen width equals screen width, and this dot screen height equals screen height. Now the sprite's going to have to load its bitmaps, or it's going to have to get its bitmaps from somewhere. So I think that being so, let's maybe give it an init method, public void init. Now what this accepts depends on what you kind of need to initialize your sprite with, I suppose. And I'm going to give my sprites at the minimum 2 graphics, which are going to be, it's going to have like a main graphic that actually displays the actual sprite, but it's also going to have a shadow as well, which I've kept separate. And as I said before, you don't have to have a separate shadow, but just for the purposes of this game, I'm going to give it a separate shadow. So to the init method, I'm going to pass 2 bitmaps, a bitmap which I'll call image maybe, and a bitmap which I'll call shadow. And again, this is very specific to this particular little demo game, and you won't necessarily want to have the same 2 bitmaps. And I'm going to store those up here, so private bitmap image and private bitmap shadow, because I think that I'm going to do the actual loading of these bitmaps somewhere other than the sprite, because I feel a bit unhappy about the idea of passing in the resources object to the actual sprites, because then I'd be passing in a sort of quite a high level object to quite a low level object, which is not necessarily bad, but I somehow feel as though it's better to load stuff higher up the method hierarchy, higher up the class hierarchy, or the higher up the method stack, and then just pass in the bitmaps here, so to keep this sprite class relatively lightweight and to keep it away from dealing with loading resources and stuff like that. Now in draw, we're gonna just draw the image and the shadow, so I'll draw the shadow first because the image has got to go on top of it, and I'll just say canvas.draw, and I want this draw bitmap, this one, well not actually that one, but probably this one, and I'll draw the shadow, and left is going to be X and top is going to be Y, and paint is going to be null because I don't think I'm going to be using that. And then same again for the actual image, and the update is going to the kind of update method, what that contains is going to depend on the actual particular sprite that I'm implementing. But now that I think of it, probably what I'll do later on is remove that from here and put it in more specific classes, because I'm not sure that I necessarily want to give every sprite an update, because for example my bat, which is going to be controlled by the player, probably won't need an update method because it doesn't have any kind of internal updating to do. So that's my sprite class, and let's just see now if we can go ahead and use that in the game. So let's see, yeah, so I'll go to game here, and init would be the logical place to load sprites, and init is not called at the moment, so I'm going to go to game runner, and game runner calls update and draw, but before it goes into the game loop, which is here, let's just put a comment, game loop, I could do an init, so I could say here game.init, which is probably a reasonable place to do it. And by that time the game already has a surface holder and a resource object, so I could make use of those there. And I'm gonna, let's give game for the moment a private sprite ball, and this can be my kind of ball object, and although it's sort of a flattened ball in the case of these graphics that I'm using. And in init I could load that, I could say ball equals new sprite for the moment, just to get this working. And if I look at sprite, so that accepts the screen width and the screen height, so I could pass that in by saying, I think I can anyway. I don't know if we can get the screen width and the screen height from the holder actually. Probably I'd have to say holder.get surface.get. In fact, I don't even think we can get it here, which is a bit annoying. So I might have to rethink that. Yeah. Well, I could do something like in my game view. When I create the game, I could pass the width and height there into the game. Like I could say get width and get height. That might work. Let's go to game and say int width and int height. Well, we'll soon know if it works or not. And I'll go to, yeah, if I go to sprite, here I'm storing the screen width and the screen height. So let's just copy those and paste those into game, because I need to store them in game as well. And here I'll say this dot width, this dot screen width equals width, and this dot screen height equals height. I always feel with this kind of stuff as though there must be a more elegant way of doing this, but I guess I haven't done enough of it to really have a feel for what that is. And in here we can pass in screen width and screen height, and so we've created the sprite, and I need to initialize the sprite with bitmaps. Now I've already got some code in my main activity, actually in the game view, I think, that loads bitmaps. Here we go, we've got this. So if I just cut that for the moment and then go back to sprite, in init, no, not in init, yeah, in game view actually, no, in game, bear with me. Yeah, so in game, here I plan to initialize my sprite. So that means that I can load a bitmap here and pass it to the sprite. So I can say, let's say bitmap, let's call it ball equals bitmap factory.decode resource, and I pass in my resource object, resources. Let's rename that to resources actually, and here I pass in resources, r.drawable.button, so that's my ball image, let's say, and just add the import for bitmap, and let's expand the editor here, format the code, and then I can pass in the ball shadow. So ball shadow, and my ID for that is button shadow. Actually, I called the actual image button for some reason, and in fact, maybe instead of storing the screen width and screen height, I could just use it in the constructor. So I could actually call my sprite constructors in the constructor and then call init and init. That has a certain elegance to it. In fact, I'll delete this here, and let's just do that. And this is going to be screen width. This is going to be width and height. So I think we're almost there now, and I can say here ball.init and pass it the ball image and ball shadow. And now we're getting to the magic bit, because in draw now I can go ahead and try and draw this ball, and to do that I need to get a canvas, which I don't think I did in my game runner. Sometimes I do, but here I haven't. So in draw I'm going to say canvas equals, actually let me just check in game view. Yeah, we've already gone through locking the canvas here. So in fact I'm going to take this code out of here, and I'm going to do Control X on that, and for the moment I'm just going to return true from on touch event and not do anything with it yet. And then in draw, let's paste that code in. So we lock the canvas in draw. This is in game.draw, and if it's not null, then we can draw our sprites. So I can say ball.draw canvas, and I think that ought to work. And let's run it and see. I'm not sure if I missed anything, but we'll give it a go. So I hope that's not too confusing, because as you can tell, I'm still kind of slightly deciding in my own mind how best to structure this. But the bottom line is that we've got this game runner that's running the game loop, and that's calling on the game init, update and draw, and then game is going to have a bunch of different sprites, and for all those different sprites game calls init, and in update it's going to tell the sprites to update themselves, and in draw it will tell the sprites to draw themselves. And the only complication here, and the annoying stuff that I can never figure out to my own satisfaction, is the stuff having to do with passing around global resources like width and height, because I don't really want to make them totally global with a singleton or something, and passing them around always feels a bit messy, but this does the trick. Okay, so that's running on my phone now, and I'll just show you that. This is what it looks like, and it looks terrible, and the reason for that is that I haven't drawn a colour in the background. So let's just fix that before we leave this tutorial. And in game, in draw, if I've locked the canvas, I actually just want to say canvas.draw color.white to give it a white background in this case, and let's run that. And probably what I'm going to look at in the next tutorial is probably creating some more sprites, or actually no, it would be quite exciting to actually get this ball to bounce around the screen, so maybe we'll look at that, and that's certainly something that we need to do. Okay, so let's check on progress. It's now starting, and I'll show you my phone. Here it is. So we've got the ball on the screen. So we're back to where we were several tutorials ago, but the great thing is we've now got a structure in place, and we're now running a game loop, and all we have to do now is put some code in update, and this ball will actually move around the screen, believe it or not. So that's it for this tutorial. Thank you for bearing with me with all my dithering about heights and widths, and until next time, happy coding. Hello, this is John from caveofprogramming.com, and in this tutorial I'm going to make the ball actually bounce around the screen, and it's not going to be perfect by the time we finish this tutorial because we've still got to consider stuff like the difference between the size of the bitmap and the size of the ball, because I've actually got a bitmap here that's bigger than the ball, which actually I could have fixed, but I'm going to kind of fix that later using a technique that you might find useful. But let's just get it moving for the moment because that's going to be a little bit exciting. So I'm going to right click my package here and go to new class, and let's have a class called ball, and I'll click finish, and I'm going to say ball extends sprite, and do Ctrl-Shift-O to add the input for sprite there. Let's see what's wrong with this, and I need to add a constructor here, so I'll add that, which just calls the superclass constructor, and the sprite class is this one I've defined in the last tutorial here. Now for the ball's going to need some update code, so I'm just going to cut this method out of here because I think that in general I'm not going to force my sprites to have an update method. Like, I could make this an abstract class and give it an abstract update method, but I think not every sprite is going to need to update itself, as we'll see. So I'll paste that into ball, which is going to need an update method. And in update now I just need to do stuff to change the location of the ball, basically. And let's go to game, and that's where I'm using this sprite class, but I'm going to change this to the ball class to use that instead of sprite. And now I'm going to give this ball a private float x speed, or maybe I'll call it speed x, and a private float speed y. And in fact I'm going to just hard code these because I think I'm not going to change these. Let's say private final float speed x, and let's try 0.5 and see how that goes, and private final float speed y equals 0.5. and in case you didn't guess, this is going to be the speed in the x direction, and this is going to be the speed in the y direction, or the vertical speed. And I need to put f there because it's a float on the end of that number, and I'm also going to give it a private int direction. Let's well, x let's say, or direction x, yeah, direction x, and I'll set that equal to maybe 1, and private int direction y equals 1. And this is going to be, of course, the direction that it's heading in x or y, and I'm going to use these to control the bounce of the ball, basically. And now to calculate the new position of the ball, I'm going to say, well, I want to access x and y, but in the sprite superclass here, x and y are private, so I can't access them even in child classes. And rather than expose them to child classes, which makes the child class very dependent on the precise implementation in the parent class, rather than do that, I'm just going to right click here and go to source, generate getters and setters, and I'm just going to generate getters and setters for them. And then, as long as the getters and setters don't change, I could happily get rid of these if I wanted and replace them with something else. So in update I want to say float x equals get x and float y equals get y, and then I want to do something to them, like x equals direction x times speed x, and actually I don't want to say equals, I want to say plus equals. So we're going to add to x the direction times the speed, and I'm also going to multiply there by the elapsed. So this is just going to be plus or minus 1 direction, and speed obviously controls how fast it goes, and we need to make the distance that it moves, the distance that we add to x, proportional to the elapsed time, which is in milliseconds. So I'm multiplying by elapsed, so that if we have a long period between since update was called last, then it's going to move a correspondingly long distance. It's going to be the same for y, so I'm going to say y plus equals direction y times speed y times elapsed. And then finally we can say set x, x, and set y, y. Now in between here I'm going to need some code that stops it flying off the edge of the screen. But let's just run it now and see how it looks. So I'm looking at my phone, and for some reason the list of numbers is showing, which I don't want to expose to public scrutiny, but if I can just get rid of that. And yeah, here's how it looks now, and whoops, where are we going? So it's static at the moment, and the reason for that is that I forgot to call update. So I'm going to go into a game now, and now in here I'm going to say ball.update elapsed. I'm going to run this, and let's go back to my game here, and if we're lucky we're going to see a moving ball in just a second. And actually I could make it bounce around the screen, but maybe I should save that for a future tutorial. Well, let's see how this goes. And here we go. There's no sign of the ball at all. I don't know why not. Well, hopefully we've initialized the sprite, so the sprite's been initialized with quite reasonable values, and it may be that the values that I'm setting for x and y, well, they must be off the edge of the screen, and it may be that speed x and speed y are simply much too great. Let's just put a log d in here and say x is plus x, and what I'll do to give it a fighting chance is I'll put 0 in here, and I'll run that, and I have to add the import for log.d, and I'll run this. So finally my ball is on the screen, and it's moving in crazy leaps towards the edge, which isn't quite what I expected. I'm not really sure why it's so lacking in smoothness, and that's something that I'll have to look into, but I think we'll leave it there for now, and in the next tutorial we'll look at actually making the ball bounce off the edges of the screen. And I think I have a little problem with my phone or something at the moment, because there's no reason that I can see why this animation shouldn't be smoother, and I think the code is fine, and I hope to demonstrate it working very nicely in the next tutorial. Okay, so that's it for this time, and until next time, happy coding. Hello, this is John from caveofprogramming.com, and in this tutorial I'm going to animate my ball sprite so that it moves around the screen, so it bounces around the screen. And a lot of what we're going to do from now on is not going to be Android specific. And if you just want to look at the Android specific stuff, then you probably want to skip ahead till the stuff that we're going to do on sound, because I think until then probably there's going to be some stuff on getting touch coordinates, but most of what we're going to do here is going to be kind of general kind of game programming type stuff until we get to the sound bit. And at the moment what I've got is, if I go to my game, let's go to all apps here and start my game from the icon, then it starts off with a ball, and this is actually moving smoothly, but the problem is that on the screencast it looks jerky, which is annoying. But if I run it in an emulator it's just as bad. So in fact I'm not even sure if it runs in an emulator. I think last time I tried it didn't work. So I'm afraid I'm going to have to ask you to bear with me and to trust me that it does actually move smoothly in real life. And in real life the actual drawing looks quite a lot nicer as well, because the screencast expands it to like 1.5 times its actual size. So at the moment the ball just plows ahead and jumps right off the screen, and what I need is some code in update here to detect when it hits the edge and to make it change direction. And I'm going to do that initially crudely, but we'll at least get it basically working in this tutorial. And I need to give this sprite class methods for getting the actual bounding rectangle of this image. So I'm going to give it a method called public rect get rect, which sounds like a command to get very, very drunk if you're from Britain, get wrecked, but it's actually get the rectangle that bounds the actual image is the meaning of it. And I'm going to, up here, let's create a private rect, let's call this bounds, and yeah, that should do the trick. Let's have the input for rect there. And to calculate this rectangle, what I'll do is, in init, where we load the image, I can then say bounds equals new rect. And if I just do control space, we can see how the constructor parameters work. And we've got the left, top, right and bottom of the rectangle, and this is going to be relative to the image, so the left and top are going to be 0, 0. The y coordinate is actually goes from the top down, so the topmost bit is going to be 0. So what was that? Left, top, right and bottom, and the right is going to be image dot width, get width, and bottom image dot get height. And now that's the bounds relative to the bitmap itself, and I can return that in get rect. So I can say return bounds, but I also need I need to know the rectangle actually on the screen. So I'm going to give it a public rect get screen rect as well, and this is going to return the kind of the rectangle that the image covers actually on the screen. And to do that, I'm going to say rect screen, actually let's call it rect equals new rect, and the left is going to be bounds.get well actually it's going to just be x, isn't it? It's going to be x, and the y, be nice if I could get the constructor here. Let's do control space. Left, top, right and bottom. So the left is going to be x, right is going to be x plus bounds dot, let's say get bounds. Oh, I called it get rect. Yeah, that's good. Get rect dot width. So is that right? So the constructor's left, top, right, bottom. What am I doing? This is all wrong. Okay, the left is X, the top is Y, left top, right is X plus get rect dot width, and height, and the, I can't keep this in my head, left top, right, bottom, and the bottom is going to be Y plus get rect dot height. I think we're there. So this is the same rectangle, it's the same size as this rectangle. The only difference is we've got to add X and Y onto, X adds onto any coordinate, any horizontal coordinate, and Y adds onto any vertical coordinate, and then we can return that. In fact, why not do this all in one step and just say return new rect? I think that should do the trick. Now there's an error here, and that's going to be because I have to use integers for the constructor here, which is a bit annoying. And I suppose I could say, because like width is returning, well, X is certainly a float, I could just put a bunch of typecasts in here, and by the time we're talking about the screen, then everything has to be boiled down to an integer anyway, because the screen's obviously, screen positions are specified in pixels, so it wouldn't do, there's no point in trying to specify the screen rect in terms of floating point values, because it's got to be boiled down to integers anyway. So I'll use a typecast. I could use math.round if I want to be really finicky, but I think that for our purposes here, just casting to an integer, which would chop off any part that goes over the lower bounding integer value, would be fine. So, you know, if we say 8.9 and we cast it to an int, we're going to get 8. But I think that's fine for our purposes here. Now I can go ahead and use that to make the ball bounce, because I can say here, so after we add the actual kind of speed and direction, I can then say rect screen rect equals get screen rect. So this is telling me the rectangle of this ball actually on the screen, and then I can say if screen rect dot get dot X, is probably what I want, I think, screen rect dot left, that's the one, is less than or equal to 0, then obviously that's no good. So what I need to do is I need to say that the X direction is then 1. So that like the X direction is going to be -1 or +1, and it's going to be -1 if we're heading left and +1 if we're heading right, because if it's +1 then we're going to add the speed, which is always positive, times the elapsed time onto X, which will move it to the right. And in fact, let's do the addition down here like that. So if the left corner of that rectangle is off the screen to the left, this says, then make sure change the direction to 1. I mean, because presumably the direction must be -1, and that was how the left got to be less than 0. So we're going to make sure it's 1, and then we're going to be adding to X to move it back towards the right. I'm going to say else if screen rect dot right is greater than or equal to the screen width, and this is what we need the screen width here for, and actually I need to have get methods in my sprite for the screen width and screen height. Let's go ahead and define those, because the sprite does have this information. So I'll right click and go to source, generate getters and setters, and I don't think I need setters, but let's tick get screen height, get screen width, and that should do the trick. And so here I'm going to say if screen.right is greater than or equal to get screen width, then I need to turn the ball back the other way and say direction X equals -1. and it's going to be exactly the same again for y basically. So if screen rect dot top, and remember that we numbered down from the top down on the y-axis, so top is going to be the smaller coordinate. So if screen dot top is less than 0, it means it's off the top of the screen. When you want to say direction y is going to be 1. And else if screen rect dot bottom is greater than or equal to, and this one's going to be get screen height, then direction y is going to be -1. We want to start subtracting from y, and I need the equal sign in there. Now if I've got this right, now we're going to see the ball bouncing crudely around the screen. It's going to be crude because, well, firstly you're going to see it as being crude because my emulator, my screencast won't keep up with my phone, but also because this screen rect is the rectangle of the entire bitmap instead of just being the ball. So it's not going to be perfect, but well, you know what, I forgot to start my emulator, so I'll be back in one tick. Okay, did I say emulator? I meant screencast, but anyway, here it is, it's running, and although it appears jerky to you, unfortunately, it is actually animating smoothly, and the ball doesn't look as jagged as it does, unfortunately, on this emulator. And you can see that it's bouncing around the screen, but you'll notice that it's not hitting the exact edge of the screen. It appears to stop short of it, and that is because the bitmap has a transparent background which is bigger than the actual image. And to fix that, the sensible and efficient way of doing it would be to make your bitmap fit your image precisely. And I haven't done that just because I want to combine this image with its shadow. And if I made the actual bitmap smaller to fit the actual image that's on it, the actual non-transparent bit, I'd have to then manually line up the shadow with it, which would be a good thing to do. But just for kicks, and because I'm very lazy, what I'm going to do is, rather than fill about with pixels manually and try and align the two correctly, what I'm going to do is I'm going to just write a little algorithm in the next tutorial which is going to find the non-transparent region of that bitmap. So we'll do that next time so that the ball will bounce more precisely, and I'll leave it there for this time, and until next time, happy coding. Hello, this is John from caveofprogramming.com, and in this tutorial I'm not going to do any coding just because the coding that I've done since the last tutorial, which I'm going to explain to you now, is very, very minimal, and most of what I've done is kind of graphically orientated, and it's not necessarily going to be useful to you. And I did have it in mind to show you an algorithm in this tutorial that finds the bounding box of the visible area of the bitmap. But what I realized is, after thinking about it, that's such an inefficient thing to do. And if you've got an area in your bitmap that's the bounding box and some of it's transparent, it's much better just to hard code the bounding rectangle values than it is to keep finding it all the time over and over again whenever you run your game. So what I've done is I went to GIMP and I just ran this image auto crop image feature, and that removes any transparent areas of the image except for the bits that are needed to make it kind of rectangular or square. So I've got rid of most of the transparent parts of my image and my shadow, and that left me with a little problem, which is that now if I put the image on directly on top of the shadow won't be in the right place. In fact, I could actually have removed a lot more from this shadow, because the only bit that you actually see is this bit on the left here, and the middle bit is obscured by the actual image. So if I wanted to be more efficient, really I should remove even more of the shadow. But I've cropped them down both quite a lot, and what I did was, in the init method of my sprite class, this is where I'm supplying the bitmaps, the shadow and the image. I'm also now supplying a shadow offset X and a shadow offset Y, and I just store those in private instance variables in sprite.java, and then when I draw the shadow, I add the shadow offset X and to the X coordinate of the shadow, and I add the shadow offset Y to the Y coordinate of the shadow, and then when I call sprite.init, I supply offsets that move the shadow to the right place. So it's very, very simple, and the end result is this. But the great thing about it now is that I actually commented out this update just temporarily. But now if we allow the ball to bounce again by running update ball.update, then the great thing is that the bounding box of the image really is the bounding box of my sprite now, and that means that with a bit of luck, luck shouldn't really be necessary, but hopefully the ball will now hit the edges of the screen. And the alternative to that, which I was going to do, was define the bounding area programmatically, and then when I check in my ball to see where it's hit the edges of the screen, I was going to check it against a bounding box that I'd defined programmatically somehow, but that was ridiculous really. This way is much better. So now it actually doesn't look perfect. Oh, it does look perfect. You know what? The ball is actually hitting the exact edges of the screen, but because the screencast is slow and it only updates every few frames, you don't see the actual edge of the bounce. But so you're going to unfortunately have to take my word for it that now we've got the bounding box right, and I've trimmed down the image to get rid of all the extra transparent stuff. It is actually perfectly hitting the edge of the screen. So that's it for this tutorial, and until next time, happy. Hello, this is John from caveofprogramming.com, and in this tutorial I'm going to add a couple of bats to this little sort of demo game. So I'm just going to draw them in this tutorial, and we'll make them work in future tutorials. I'll create a new bat class. So let's create a new class called bat, and click finish. And I think just for the moment I'm just going to draw both the kind of player's bat that the user controls and the opponent bat that the computer controls, both with this bat class. So I'll make that extend sprite and click the error and add a constructor. Well, I'll just add the input for sprite, and I don't know what I did wrong here. Public class bat extends sprite. It looks fine to me, and yet there's an error. Let's take a look. Oh yeah, add a constructor. Okay, yeah, that's fine. So I'll just call the super constructor in the constructor, and I'll go to game, and the way that I want to use this is I'd have a private bat player, and this is the bat that the actual player controls. And when I say bat, of course I mean like a kind of tennis, well, it's not a tennis bat, is it, but you know, like a cricket bat that hits the ball. And we'll have one called opponent, and then wherever I reference the ball, I'm going to have to reference the player and the opponent, basically, pretty much. So let's have a new player, a new player and a new opponent. That's spelt wrong. Opponent. My brain is evidently not working. Oh, that should be bat, in fact. Please bear with me, getting there in the end. Okay, there we go. So we're creating new bat objects, and the error here is that, yeah, this has to be player and opponent. I think the cold here is maybe affecting my brain. It's like -5 or something, and I've just been out on it. And let's go down here and init the player and the opponent. So this is going to be player and opponent. So in the init method of game, where we initialize the ball, we also initialize the player and the opponent bats. I'm not going to give the player or opponent update methods just yet, and they may not both need them. And I'm going to say player.draw on the canvas, and bat.draw on the canvas. Now I have to also initialize these with the correct opponent.draw. Okay, there we go. That's right. Okay, now I have to initialize these with the correct images. So at the moment I'm using the ball image, which is no good. So let's load the bat image that I've got, and I'll use the same image for both. So I'll copy the ball stuff and I'll change that to bat image and bat shadow, and for the bat image I want it's called bat and it's in the drawable folder, and I've got a bat shadow in the drawable folder as well. And I think I'll leave the other settings the same. So for player we want bat image, bat shadow, and for the opponent we also want bat image, bat shadow, and I don't know what the offset of the shadow should be, but we'll try the same one as the ball for a start. Now if I were to run this, what would determine where they appear on the screen would be that in sprite here I'm setting the location of a sprite to 30 pixels, well, to 3030, the coordinate 3030 basically by default, which isn't really so good. And I want to think about actually where the ball should appear initially, but I'll worry about that probably later on. And what I'd like to do here is make sure that the player and opponent bats initially appear in the center of the screen. So if I go to the screencast here, I want the player to appear roughly here in the middle in the center, and the opponent to appear roughly here in the middle in the center. So to position themselves, the bats have to know the size of the screen, otherwise how can they know where the left edge is, for example? How can they know what's halfway vertically unless they know the size of the screen? And when I construct the sprite, I'm passing it its width and its height, and if I look at the sprite constructor, the width and the height is set there, and that's where I'm setting the width and the height of the ball, the position of the ball. So I guess yeah, I was going to say what I could do is I could, in the bat constructor, I could then, after calling super, I could position the bat. But the problem with that is that the way I've written it, we don't know the size of the bat at that point. And the coordinates x and y refer to the top left hand corner of the image, not the center of the image. So if I were to position x and y at half of the screen width, let's say half the screen height, and 30 or something for x, it's not going to be halfway down the screen. The top left hand corner of it will be halfway down the screen. What the information that I need to position the bat correctly is both the screen width, the screen height, and also the actual bitmap sizes that I only get in the init method. So what I'll do is I'll make sure that the init method can access the size of the screen and the height, which it can. I think I might have just added this after the last tutorial as well. So I was passing the screen width and screen height to the constructor, and I think I might just have added this. So if you're following this along step by step, you might want to add this now. Just make sure that after you pass the screen width and screen height into the constructor, you have a private screen width and screen height in sprite.java, and you initialize it from the values that are passed into the constructor, because that will mean that you can then access those values in the init method. And then I'm going to go to my bat.java, and I'm going to right click and go to source, override implement methods, and override the init method from sprite. And I'll call the superclass method. And now I can initialize my bat location. In fact, what I'll also do is I'll go to sprite here, because I've made screen width and screen height member variables. I made them private. I'm just gonna go down here. Yeah, we've got to get screen width and get screen height, and perhaps I added those in a previous tutorial. I can't remember, but I might have just added them just like an hour ago off outside this video. I don't know. But anyway, once you've got those, then in init you could then say, well, let's say that we want to position the bat either on the left hand side or the right hand side. So what I'll do is I'll give this a public enum position, and I'll give this the values left and right, and then I'll have a private variable of type position called position, and I'll initialize that somewhere. So let's say that the bat, maybe the constructor, could take like a position, and then I can say here in the constructor, this dot position equals position. And now if I save that, we should get an error in game.java, and right where I initialize the bats, then I can say for the player, let's say bat.position.left, and for the opponent I will set that to bat.position.right, and save that. And now back in bat.java, so we've got this private position, which is this enum type, set to something meaningful. And then in init I can say if position equals position.left, then where would we position the bat? Well, let's say that we want it some distance from the left hand edge of the screen. Let's have a private static final int margin and set that equal to, let's try 20, and I want this to specify the distance of a bat on the left from the left hand edge, or a bat on the right from the right hand edge of the screen. So if the bat's positioned on the left, then we can say that the x position, I can say set x, should be the margin. That's pretty simple. Is that right? Yeah, I think that's right. And then the y position, set y, that's going to be a little bit more complex, because we need to take the screen height divided by 2. Screen height divided by 2 will give us, I need to say get screen height, because because screen height is private in the parent class, so I can't access it directly here, but I can access the accessor method. So get screen height divided by 2. Then I need to subtract from that, and I need to subtract something like half of the height of the actual bat itself to get that to be actually in the middle of the screen. So to do that, there's this get bounds method, I think, get rect, maybe, yeah, get rect. Get rect is set, I think, in sprite in init, sprite.init. It's set to the bounding rectangle of the whole image. So if I say get minus getrect dot center y, I think that will do the trick, because getrect dot center y, this gives me the y position, with the 0 of y being the top edge of the graphic. So this is you might even, if you haven't done this kind of stuff before, you might even want to sort of draw it out to get your head around it. But if you imagine that the graphic is, well, let's go to the image here. Imagine that this whole thing is a bat graphic, this whole screen. Then the 0 of y will be the top edge here, and the center y would be a position down here. And if from the top edge to the center is, say, 200 pixels, then center y will be 200. So by subtracting that from the center position vertically on the screen, we position the center of the bat in the center of the screen. And I feel I'm not explaining this very well, but if you draw it out, hopefully you'll see that that's the case. And let's go on here and do the right position. So I'll say if position equals position dot right, that's position capital P dot right, then actually the Y position is going to be the same, so I can just take that out and put it up here. It's only the X position that's different, and the X position will be set X, and I need to say, well, it should be get screen width negative margin minus the margin. But again, we've got the same problem, because this will position the top left hand corner, or the left hand edge if you like, of the sprite at this particular X position. And I don't want to position the left hand edge, I want to position the center of the sprite at this position. So therefore I have to subtract half the width of the sprite. And just to make this a bit clearer, I'll put brackets around all this, and I'll subtract get rect dot center X to again subtract. This is basically amounts to half the width of the sprite, and this is half the height of the sprite basically. So I think that's okay, that's all okay. We've got some sort of error here. Let's just take a look. I meant to say else if, and I'll save that. And I think this is all good. So if I run this now, with a bit of luck, we're going to see the bats appearing on the screen. And if it all looks good, the next step now could be to actually start making a move. And we also need to attend to the position of the ball, and I think I'm probably going to do something similar with the ball as well, and I'll maybe give it a random direction to start with. So let's just take a look at my screencast now, and there we go. We've got bats, well, you can see where they are, and I think that looks just about right. They're quite big. Actually, it looks better on my phone once more. And since this is just a demo game and I'm not intending it to be the latest smash hit game, I'm just going to leave it at this because it demonstrates the principle reasonably well. Okay, so that's it for this tutorial. I hope you could follow that, and I hope my explanation wasn't too convoluted. And until next time, happy coding. Hello, this is John from caveofprogramming.com, and this is just a little tutorial in which I'm going to put this ball in the center of the screen to start off with, and I'm going to randomize the direction of it. So this should be pretty simple. To position the ball, we can use the same technique that we used for the bat here. So if I let's just comment out that log D actually. So if I go into my ball class here and I right click and I go to source override implement methods, we can override the init method from sprite, and I'll call the superclass method. And now we've got access to the size of the ball bitmap and the size of the screen. So I can say setX, and setX will be get screen height over 2 minus get rect dot center X. No, that's wrong, isn't it? It should be get screen width over 2 minus get rect dot center X. So same logic as for the bat. We this in itself will position the top left hand corner in the center of the screen, and then we need to subtract half the width of the graphic to actually get the center in the center of the screen. And of course for Y it's pretty much the same. So I'm going to say set Y get screen height over 2 and get rect dot minus get rect dot center Y. That should put the ball directly in the center of the screen. And to set the direction of it, I'd like to set the direction randomly to start with, because at the moment I'm setting it to 1. And in fact, let's just go to Sprite and take out these initial values for the coordinate, and I'll put them to 0. And so it should be pretty obvious if the user of these classes, which is me in this case, forgets to set the position of them. And I don't want to initialize the direction to 1. Actually, in fact, come to think of it, in Sprite.java we don't even need to do that, because because instance variables are initialized anyway by default, so they would be 0 if left to themselves. So let's just leave them. Now I won't initialize the directions, so they will be set to 0 by themselves, but the direction should be either 1 or -1. And for x, 1 would mean heading to the right, and -1 would mean heading to the left. And we use it down here to multiply the speed and the time elapsed to actually get the final direction. So all the directions do is say whether the direction is kind of in a direction of the increasing coordinate value or decreasing. So the direction should be either -1 or 1. And the question is, how can we get a random, how can we either get 1 or -1 at random? And to do that we can use the random class. So in bool here, now where would a good place for this be? I can do this on the constructor, I suppose. So I don't really need to do it in init, but actually init is a perfectly good place as well. So let's do it there. Let's say random equals new random. This is a built-in Java class, which we can also use, of course, in Android. And I'm going to say that direction x equals random.nextInt. And random has this method nextInt, which it can take an integer and we're going to pass it 2, and it will give you a random integer up to but not including that value. So if you say nextInt 3, let's say, you'll get 3 random values. You know, it could be the random value will be one of 3 possible values, 0, 1 or 2. So if we pass it 2, we'll get one of 2 possible random values, which will be 0 or 1. If we multiply that by 2, the random values will now be 0 or 2, because 0 times 2 is still 0 and 1 times 2 is 2. And if we then subtract 1, that maps 0 and 2 to -1 and 1. So this gives us exactly what we want. This will give us either -1 or +1. And I'll do the same thing with y, and direction y equals another random number, either -1 or +1, and that should be it. So I'll just run this, and now the ball should appear initially in the center of the screen, and it should have a random direction. Let's try to go really quickly to the screencast, so hopefully we can catch it starting up, and it hopefully will be on its way. And while we're waiting for that, let me tell you what I'm thinking of doing next, which is it would be quite good if we make the player's bat, be controllable by touching the screen. So probably we'll do that next. So there we go. The ball seemed to be in the center of the screen, and we'll take it for granted that the random direction worked, although you could start it up a few times if you want to check that, and you'll see that sometimes it's going to the left, sometimes to the right, and sometimes up and sometimes down. Okay, so that's it for this tutorial, and until next time, happy coding. Hello, this is John from caveofprogramming.com, and in this tutorial I'm going to make the left-hand bat here controllable by the player. So to do that, if we go to Game View here, Game View is receiving on touch events, and we are returning true, and returning true has the effect that if you receive a touch event, I think it's called a down event or a press event, I can't quite remember, then you will then receive kind of drag events or motion events, and if you return false, then you'd still kind of receive the down event, but you wouldn't receive the drag events following that. So you have to return true to say that you've handled the event. and I want to pass these events onto the game. So I probably just want to say something like game dot on touch event and just pass this straight through, pass the event straight through. So let's just write that, and I'll click this and create the method in the game. So now we've got an on touch event in the game, and now I want to handle this by saying, well, you see there are various different kinds of events. I could say something like event.get, I think it's get action, and I could say if that is equal to motion event dot action down, for example, or if it's equal to action move and that sort of thing. I could take different events depending on whether the user is moving their finger around, or they've just pressed it down, or they've just released their finger. Probably there's an action up, is there? Yeah, I think so. But I don't think I'm going to need to use these here, because in this game, if the user touches the screen and moves their finger, or it doesn't really matter, I just want to move the bat to the corresponding vertical position. So I don't really need to differentiate between these different kinds of events. So probably all I need to do is say something like player, which is the player's bat, dot set position, and I haven't created this method yet, but I will. And I can pass in event dot get x and event dot get. Actually, I don't need event dot get. I don't need event dot get x, because I'm not going to move the bats horizontally. I'm only going to move them. Just take a look at the screencast here. I'm just going to move them up and down, and you can make the handling of these bats a lot nicer than I'm going to. But I'm just going to show you something really simple just to kind of get this implemented and working. So you could, for example, check when the user touches the screen. You could check, have they actually touched the bat, and if so, you could note where they touch the bat, and then if they move their finger, you could allow them to basically drag the bat via the point that they've actually touched. Or you could do something like move the, what I'm going to do is I'm just going to move the center of the bat immediately to wherever they touched on the screen vertically, and not worry about making it nice, you know. So I'll click this error, and we'll go to create method set position in type bat, and this has got to set the vertical position of the bat. And to do that, I'm just going to say set y, and I'll pass in y and subtract once again get rect dot center y, so that we move the center of the bat to the point that the player touched, rather than moving the top left hand edge to the, well, rather than moving the top of the bat to the point that the player touched, which would look quite rubbish. With the other bat, it's going to be a little bit more complicated, because I'm going to have the computer control it. But I've got a very simple algorithm that I've been playing around with, and we're just going to implement that to try to make the game look playable and look like the computer's controlling it in something vaguely resembling a sensible manner. So here we are. And now if I touch the screen on my phone, I'm moving the bat to where I touch it. Actually, I can touch anywhere on the screen, because I haven't checked that the point that I've touched is actually on the bat. So I just touch the screen in some position that I want to move the bat to, and the bat moves there. It looks horribly jerky on the screencast, but on my phone it's nice and responsive. Okay, so that's it for this tutorial. And in the next tutorial, we'll put some intelligence into the opponent bat. So join me again then, and until next time, happy coding. Hello, this is John from caveofprogramming.com, and in this tutorial, I'm going to make the opponent bat here move automatically to try to intercept the ball. Although at the moment the ball's still not bouncing off the bat, so we'll have to fix that shortly. And I was thinking that we were going to have separate classes for the two different kinds of bat, the opponent and the player, but I've realised that we can actually get by just fine with just having one bat class, because the game only sends touch events to the player bat. I don't know why there's suddenly an error in here, because this is working. Well, anyway, we only send touch events to the player bat, and we're only going to update the position of the opponent bat. So when we call, in here we're going to call player.update, but we're not going to call, we're going to call opponent.update, but we're not going to call player.update. And I don't know what's going on here. So let's just take a look at this error. So it says that set position float is undefined for the type bat, and yet I just showed you code that was working, and I haven't changed it since then. Maybe I'm looking at a game. I think I was looking at a game file from a different project. My apologies. Okay, so let's carry on. So what I need to do is I need to add an update method to this bat, which I then call in the game class. Let's go to game here. It will help if we go to game in the right project. So this is the game. It's my game class, and I'm updating the ball, and let's now call opponent.update and pass the elapsed time to that. And I'll save that and then click on this error and go to create method update and type bat. So I only call opponent.update, I don't call player.update, because the player, the actual human player, will control the position of the player bat. So here's my newly created method, and now what I can do in there is just put some intelligence that controls the position of the bat. And the first thing I'm going to do is I'm going to, in this bat class, I keep thinking of Batman for some reason. I'm going to give it a private random equals new random. So we need a random number generator. And I think I'm not using this. I'm not using a random number generator yet anywhere in here. So let's add the input, Control-Shift-O. And in update, what I'm going to do is, and this is a really simple algorithm that I figured out very quickly, so I'm sure you could think of one that's much better, but I'm just going to firstly get a random number from the random number generator. I'm going to say, I'll call it decision, and I'll say int decision equals random.nextInt 20. So that's going to give me a random number with 20 different possibilities. So it's going to be from 0 up to and including 19, but it will never actually be 20. And then I'm going to say if decision is equal to 0, and if the decision's equal to 0, well, what I'll do is I'll also give this a direction. So I'll say private dir and private int dir direction, and I'll just save that. And in init here I'm going to initialize dir to either -1 or +1, or am I? Yeah, let's do that. So I'll say dir equals random.nextInt, and we'll use the same technique as before. I'll say random.nextInt 2, so that gives us a random number that's either 0 or 1, and I multiply that by 2, and now it's either 0 or 2, and I subtract 1, and now it's either -1 or +1. So the direction is initialized randomly to -1 or +1, and this is going to be the direction in the y direction. So it's going to mean either up or down. And when I update the position of the bat, what I'll do is I'll say int y, actually float y I think, equals get y, and later on I'll say set y, and meanwhile we'll do something to y, and what we'll do is we'll have a speed as well as a direction. So let's go to the top here in the bat class, and I'll say private float speed equals, and I'll try 4.0f, and we'll see how that goes. So a value of 4 in floating point. And in between getting the y and setting the y, I'll say that y plus equals direction times speed times elapsed. See how this looks. So the speed's going to stay the same in this algorithm, and elapsed is the elapsed time, and I'm going to intelligently change the direction to make it look as though the bat is being controlled by some entity that's attempting to hit the ball. And so I get my random decision from 0 to 19 inclusive, and I say if decision is equal to 0, I'll set the direction equal to 0. So that means the bat will not move, because this will be the stuff we add to y will be 0. And I'll say else if decision equals 1. So the idea in saying if decision equals 0 is that this will happen 1 out of every 20 times, and then another 1 out of every 20 times will say if decision is equal to 1, this will happen 1 out of every 20 times. Then we'll pick a random direction. So let's just copy this up here, paste it in here. So I'll say that the direction is randomly either -1 or +1. I suppose I could condense that into one line actually, but that will do just fine. And else if decision is less than 4. So now this is going to be happening 1 out of every 10 times, I think, because we've already handled 0 and 1, but there's still 2 and 3. They're both less than 4. So that's 2 times out of every 20, which is 1 out of every 10. Now, in that case, I'm going to move it towards the ball. And to do that, we're going to have to know where the ball is. So I'm going to go back to my game here, and when I call opponent.update, I'm going to pass it the ball so that the bat has a reference to the ball. And let's add this here to the argument list. And I'm going to say if ball.get, now I need to say ball.get screenRect, which if we just take a look at that method which we implemented, that gets the rectangle that represents the bounding rectangle of the ball actually on the screen. So if ball.get screenRect.center y, so the vertical center of the ball, if that's less than get screenRect, in other words this dot get screenRect dot center y, so if the vertical center of the ball is less than the vertical center of the bat, then let's make the direction -1. So the ball is the center of the ball is less than the center of the bat, so we want to make the direction negative so that we then decrease the y position of the bat. Else we're going to assume that the center position of the ball is going to be greater than that of the bat, or else it's directly on top of it, in which case we'll make the direction of the bat positive so that it moves, well, it will be downwards, which will be towards the ball hopefully. And let's run that and we'll see if it works. I may have missed out some crucial thing, I don't know. And I kind of derived this algorithm just from fiddling about with it, and it's very simple, and you could do something much nicer. And that's actually true for this game in general. I've really I've not made it anywhere near as nice as it could be, because I just wanted to provide you with a demo. But you could do stuff, for example, like instead of the ball bouncing by just changing direction, there we go, something's happening. We could make it that the ball is always accelerating, and when it hits something it could sharply decelerate and change direction, and that would make the ball really look like it's bouncing, which would look a lot more elegant and more interesting rather than just keeping it at a constant speed. Anyway, you can see that it's working, but the problem is that it tends to disappear off the screen. So I'm going to put an extra check in here, and I'm going to say down here if, let's say if the top edge of the bat is off the screen. So if get screenRect dot top is less than 0, that means that the top edge of the bat is off the top of the screen, and I want to make dir equal to 1 to start increasing the Y position of the bat and moving it down the screen. Else if get screen rect dot bottom is greater than, in fact let's just make that less than or equal to, although that is being a bit picky. If the bottom of it is greater than or equal to the get screen height, I think we want to say, then it's going off the bottom edge, so I want to say dir equals -1. So regardless of what decision is made up here, if I want to then override that, if I see that the bat is, oops, I seem to be launching two of them at the same time, if I see that the bat is going off the screen, I want to override that with a more sensible decision that will tend to bring it back into the middle of the screen again. So this is hopefully about to run, and in fact it does run, but you can't probably see it on the emulator, but the bat's actually jumping up and down like a thing possessed at an incredible rate. So I'm just going to tweak this a bit and pause recording of this video, and I'll be back in a second. Okay, I'm back, and what I did was I changed the speed of the bat to 0.4 f, and now it looks pretty good, and you can't really see it on this screencast. In fact, the screencast seems to have frozen, but yeah, it's coming through bit by bit. But if I look at my phone, I'm sorry that you can't see this, but it does actually look quite reasonable. The bat looks a bit like it's controlled by someone who's on sort of methamphetamine or something. It's a bit hyperactive, but it is nevertheless, it's doing the trick, and it's a lot of the time it will intercept the ball, and sometimes it misses it, which is exactly what you want to give the player here a fighting chance. So that's it for this tutorial, and in the next tutorial we're going to make the ball actually bounce off the bats. So join me again then, and until next time, happy coding. Hello, this is John from caveofprogramming.com, and in this tutorial I'm going to make this ball bounce off these bats, or appear to. And actually the ball, it always moves in a constant speed in this tutorial, in this demo, as I mentioned before, which doesn't look that impressive, and it would look nice if it bounced with some acceleration. But just for this demo, I'm just going to be content if, in the event of a ball colliding with a bat, it bounces off it instead of proceeding through to the edge of the screen. So I'll go to game here, and I could give the ball a reference to the bats, both of the bats, and the ball could check the bats and change its movement appropriately. But I've already given the opponent bat a reference to the ball, and I don't really want sort of circular type references in my games. It's going to feel quite tangled. So I think what I'll do is I'll figure out the logic here in update in game.java. I'm going to find out if the ball has collided with one of the bats and tell the ball to move as appropriate. So I'm going to say if, well, let's say, yeah, if ball.get screen rect. So let's get the bounding position of the ball on the screen. And then I'll say that if the left hand side of it, in fact let's just take this out for a second, and let's say int ball, no, I won't do that. What I'll do is if, okay, sorry, bear with me, I will get the bounding rect of the player's bat. Let's do that for a start. So I'll say if player.get screen rect, and the rect class has a method called contains, which I'm going to use. So I'm going to say contains if player.get screen rect.contains, and I want to get the player is on the left hand side. It's the bat on the left hand side. So I want to find out if let's say the center pixel of the ball, on the left edge of the ball, like kind of around here, I want to know if that has collided, if this is inside this rect. So I can say if player.getScreenRect.contains, and the X, I want to say ball.getScreenRect.x. That will be the X position that I want to check for. And is that right? Or actually I need to say left. So and the Y position is going to be, I want it to be this kind of the middle of the ball. So I'm going to say getScreenRect.center Y. So this coordinate, the left hand edge of the ball and the center vertically, that's the middle point of the left hand edge of the ball. And I'm saying that if the player's bat contains that point on the ball, then I want to tell the ball to start moving right. So I'll say ball.move right, and I'll implement that. I'll click on the error and go to create method, and now I'm in the ball class, and in there I'll just say direction x equals 1, and that will set the ball moving to the right. And while I'm at it, let's just copy that, and I'll put in move left, and that will set the direction x equal to -1, which will move it to the left. And now I go back to game.java, and in there I can say, okay, we've checked to see if the center point of the left hand edge of the ball is on the player's bat, and if it is, make the ball start moving right. And I can say else if opponent.getScreenRect.contains, and this time the X will be ball.getScreenRect.right, and the Y will be ball.getScreenRect.center Y again, so the vertical center of the ball again. And I think this algorithm should work pretty well, and I'll say ball.move left if it intercepts the opponent's bat over on the right there. We also want to know what happens if the ball goes off the edge of the screen. So I want to say else if, and we're going to have to say something like if the ball.getScreenRect.left, if that's pretty far over to the left, then it means that the ball's got past the player, in which case the player has lost this particular game. But what's the definition of if it's got past the player or not? Let's say something like if it's maybe well, we're already checking to see if the ball's intercepted the player's bat, and so it could have bounced, and if it hasn't, if the left is less than player dot get screen rect dot right, so if it's less than the right hand edge of the player, then, and this hasn't been executed, so it didn't bounce off the player's bat, then the player's lost. So we can do something there like well, let's just say for the moment log.d, and I'll put my initials in there, and I'll say lost. And then finally we can tackle the situation where the player's won. So if ball.getScreenRect.right is greater than opponent.getScreenRect.left, then we say log.d tag and 1, because the ball has got past the opponent and the player has won. Let's save that and run it. One little thing that I'm slightly in doubt about is whether it might be possible somehow, because the amount that the ball moves is irregular, and the ball can sometimes move several pixels perhaps if a lot of times elapsed since last time the update was run. So is it possible that the ball could be heading directly for the bat? And no, I think this should work actually. Yeah, I was trying to think if we should allow some sort of safety margin before we say that the game's been lost, but I think this will probably work. Let's go to DDMS and go to My Debug Output, clear all previous debug output, and now I'll move the bat. Well, let me show you this because otherwise it's going to be very boring for you. Here's the game, and you can't see it. It's not looking smooth because of the emulator, but you see that the ball's bouncing off the bat safely, and I'm going to bounce it back, and the opponent's trying to get it, and it did bounce off the opponent. And let me move the bat deliberately down, and we should see that though we get lost, and we're getting lots of lost messages. And the reason for that, sometimes we get some 1-1s because the opponent misses it, which is great. We're getting lots of these messages because, of course, at the moment the ball just carries on even if the state should be lost or won, and it just bounces back anyway. So what we're going to do perhaps in the next tutorial is we're going to fix it so that when the game is lost or won, we stop the game at least temporarily at that point and display some sort of appropriate message. So that's it for this tutorial, and until next time, happy coding. Hello, this is John from caveofprogramming.com, and in this tutorial we're going to look at drawing text. And the reason for that is I want to work towards having different game states where the game can be won or lost or ready or playing. And if the game's lost, let's say, we can draw some text on the screen saying you lost. And of course you can draw text for showing a score on the screen if you like. There are lots of things you can do with it, or just messages during the game. But here I'm going to use it to draw just a screen that says you've won or you've lost or whatever. So I'm in game.java, and I'm going to rename this public void draw to public void draw game. And I'm going to create another public void draw, and I'm just going to use this to demonstrate drawing text. And I'll create a public void draw text, and I'm just going to pass this a string which will be some text to draw, and I'm only going to draw text in the center of the screen. So let's say, to test it, draw text, tap screen to start, and we'll try to draw that text just in the center of the screen. And to do this I can use a method called, well, I need a method of the canvas. So in fact, let's take this canvas locking stuff from in fact what I'll do is I'll just reorganize this a little bit slightly, and if I just copy this, copy the insides of what was draw, let's just put it back in draw for a second. What I'd like to do is in here in the middle, in the bit where the canvas is actually locked, then I'll call different methods as appropriate. So I'm just going to cut the center out of that, so we've just got the canvas locking in draw, and I might call draw text for the moment, and draw text, I'll make that take a canvas and string text. So to draw text I'll pass the canvas, which is locked, and some text saying tap screen to start. And then I'm gonna also have a public void, I've got a public void draw game, and I'm going to take the canvas locking stuff out of that, and let's get rid of all that, and we'll pass that a canvas to draw on canvas, so it can draw on that canvas. So what we've got now is I've got the draw method. So we have a draw method before that's been called by GameRunner at regular intervals, and the draw method now it just locks the canvas, and at the moment it then calls draw text and it passes a canvas to draw text with some text to draw, and we haven't implemented that yet. But what it could also do instead is it could call draw game, and draw game now takes a canvas and that actually draws the game. So we've got two draw methods, one for the game and one for drawing text, and we've got a third kind of overall draw method that can call whichever kind of sub draw method is necessary, and this kind of method that's just called draw, that now locks the canvas. Okay, so in draw text, which is what I really want to show you in this tutorial, having done that reorganization, I can draw stuff by saying canvas.draw text, and that takes some text to draw. So we pass in the text that we're passing to draw text and X and Y position, and I'm going to make this screen. I think we've got screen width, haven't we? Let's go to the top and take a look. In game I've got width and height, but I don't actually store them anywhere in game at the moment. So let's do that. So I pass to the constructor in game the screen width and the screen height, but I'm not then storing them. So, oh yeah, we can get that information from the canvas. Let's do that. So when I draw the text, I'm going to say here canvas.get width over 2, and for Y canvas.get height over 2. So we're drawing it in the middle of the canvas, and now I need to supply a paint that specifies how this text should be drawn. So I'm going to declare a paint object here, paint equals new paint, and for efficiency I could actually make this a member variable up here. It's probably a good idea. In fact, let's do that. So I'll take it out of draw text, and let's have a private paint, and I'll call this text paint. And then in the constructor, let's say text paint equals new paint, and this is the paint that we'll use to paint the text with. In other words, it specifies how the text should look. So I'm going to set some things on this. Let's make sure that we're passing it now. So when I call canvas.draw text, I want to pass it this text paint, which I'm now going to define. So canvas.draw text, it just takes the text to draw, the position to draw it at, and this paint object. And this paint object, I'll say text paint.set text align, and I'll set that to align.center to align the center of the text to the position that I say I should paint it at. So it's going to be directly in the center of the screen, as opposed to, for example, aligning the left hand side of the text with the center of the screen, which wouldn't look good. Let's say text paint.set anti-alias. I'm not sure if that's on by default or not, but it won't hurt to set that to true. Anti-aliasing makes things smooth, basically. And text paint.set, what else do we need? How about color, which I could set to color.blue maybe. And text paint.set, and I'm just using control space to look at the different possibilities. And I'm not sure if there's anything else that I really need. Well, actually, how about set text size? That's an important one, and I don't know what size to set. I'll try 26. And text paint.set text, well, set typeface, that could be a good one, and set typeface dot, and I just want to set maybe default bold, and we'll see how that looks. Okay, so I think that should work. Let's run that, and if this works, we're going to see a message in the middle of the screen that's just going to say tap screen to start, and then we can go ahead and implement some game states, so the game has a notion of when it's running and when it's been lost and all that kind of thing. Okay, so here we go, and there's one little thing I forgot, which is I forgot that I want to make the screen white and not black. So I'm gonna fix that just by having canvas.drawColor, and I'm going to make sure that I put that. I could even just take it out of here and put it in draw, so that regardless of what we draw, we'll first clear the screen, and that will look nicer. And apart from that, it's actually pretty much fine. And it looks bad because the screencast stretches it to 1.5 times normal size, but on my phone it looks really nice and smooth. So I might make it a bit smaller with the font size, but other than that, that's pretty good. So that's it for this tutorial, and until next time, happy coding. Hello, this is John from caveofprogramming.com, and in this tutorial I'm going to implement some game states so that the game's going to know when it's running, or when it's displaying a tap screen to start message, or when it's been lost. And I'm going to go into my game.java here, and let's give it a private enum, and I'll call this state. And let's say that the various possible states are paused, and pause means that it displays the tap screen to start message, and I'll have one, in which case it's going to say you won or something like that, and lost, in which case it'll say you lost. And let's also of course have running, in which case the game will actually be being played. And we could do something fancier here, like if the game's won, you could count up a certain number of milliseconds, and then after a short pause you could put it back into running or put it into paused or whatever you like. But I'll just do something really simple here, and I'll declare a variable of that type. So I'll say private state with a lowercase s, and I'll set that initially equal to state.paused. And now in draw, I'm going to say here, I'm going to say we'll lock the canvas in draw, and then I'll say switch state, so I'll switch on the state. And I'll say, in fact, the quick way of doing this is if I just click this warning here, I can say add missing case statements, and it will implement all that for me. And with a switch statement, you don't need to specify the enum type, it kind of automatically knows it. And let's say that if the game is paused, we're going to say draw text, tap screen to start. If it's lost, we're going to say you lost, and unhappy face. And if the game's been won, if the player won the game, we'll say you won, exclamation mark. And if the game is running, let's say draw game. We've got this method draw game, so I'll say draw game and pass it the canvas. And for the default, we just get rid of that really, because if I save it, it's not going to give us a warning, because those are the only possibilities, as we know, so that should do the trick. And in update, we're going to have to do a few things as well. So in the update method here, at the moment I'm doing kind of collision detection and updating the ball and the opponent, but I only want this to happen if the game's running. So let's have a actually I'll make one quick change, which is that draw text should be private and draw game should be private, because I only call these methods internally. Only the draw method should be public out of all the draw methods, because that has to be called from outside the class. And then update, I'm going to have a similar kind of system. Let's have a private update, private void update game, long elapsed. And update game is going to do all this. So I'll just copy that out of there, I'll cut it from there and paste it into update game. So I've moved the contents of update into update game, and now I can say switch state, and once again let's put the missing case statements. I'll get rid of the default one, which we don't need, and if the game's running then I say update game elapsed. And otherwise, what do? Well, I want to say that if in either of these cases, if the game has been lost or it's been won or it's paused, I think I'd like to make it so that if the user touches the screen, then the game will then start running. So let's have a private void update paused, I'll call it, and I'll pass it long elapsed, although actually I don't think I need to do that, because I'm not going to do anything really fancy here, although I could. I'm going to do something really simple, and I'll just say in the case that the game's been lost, let's call update paused. In fact, I don't think I even need to do this, because what I have in mind is that if the user touches the screen, so there's a non-touch event, and the game is in one of these states, then it switches into the running state. But I'm not going to really have to do anything in update, I don't think. So maybe it's not necessary really to have this switch. Let's just try saying if state equals state dot running. Let's try this. Then in that case I'll say update game. There we go. Maybe that's simpler, and I'll just get rid of all this. And then, so we update only does something if the game is running, otherwise it doesn't do anything. And probably just get rid of that. Actually, we don't need it. Yeah. Okay. So, and then on touch event, what I'll do is here I need to say if state equals game dot running, game equals state dot running. So if the state is running, then we're going to say player.setPosition. Else, what I want to do is, if it's not running, it must be paused. So either it's saying you won or you lost, or tap screen to start. And in either case, if the user touches the screen, I probably want to switch the state to running. So I want to say state equals, whoops, that should be a capital S there. State equals state dot running, state dot running. So I switch it into the running state. And now we need the code that so at the moment the way this works is it starts off paused, and then when it's paused, what it draws is it draws tap screen to start, and when the user taps the screen it gets a non-touch event, and we need to return true from there to receive drag event successfully. So let's, oh no we don't, this is, I'm thinking of the view touch event which returns true. Okay, so so the game starts paused, the player touches the screen, and then the game receives the touch event and it goes into the running state and it draws the game. And we want to then say, okay, what if the game's won or lost? We have to detect if it's been won or lost and switch it into the won state or the lost state, and in that state then we're gonna basically say it will be caught by this else clause here, and if the user touches the screen it'll be set back to running. So the remaining bit to do is that we have to make sure, we have to detect if the game has been lost or won and set it into the state won or lost, and then the player will get out of that state by touching the screen, which will then set it back to running, which I think is workable. So let's take a look. We've already got the code that detects if the game's lost or won, and in there we just have to say state equals state dot lost, or if it's won we say state equals state dot won. And now I think the game is complete as regards graphics. We still have sound to do, but let's check, because probably I've forgotten something. And there's no score or anything in this game, and of course there's an absolute ton of things that you could do to make this game a lot nicer and more interesting. All kinds of things. I mean, the possibilities are literally endless, but I just want to create a simple demo here, so we'll stick with this. Okay, so it says tap screen to start, so I'll tap the screen and now it's running. And actually one thing I forgot probably was to reinitialize the game. Oh, the emulator is not keeping up with my phone, and it's really annoying. My phone is actually playing, so now you can see it. And I lost, and it says you lost. And now the thing is that if I touch the screen, I've still lost because I haven't reinitialized the ball. So one thing I need to do is we know that we've lost because it detects that the left-hand edge of the ball is further left than the right-hand side of the bat, and that's how it knows that it's lost. So in the case that the game is lost or won, we need to make sure that the ball is moved back to the center. So if we look at ball now, what actually puts it in the center is the init method, which is here. So I need to give it some kind of move to center method or something like that. And this stuff here is actually moving it to the center. So let's give it a public void move to center, or maybe I could call it init position, is maybe nicer. And then I could take this positioning stuff out of here and put it in init position, and we'll just call it here and save that, and it all looks okay. And then also the bats probably should be moved back to the center, and we've got some stuff, so we don't need to worry about the X position, but the Y position is being set here in bat.java. It's being set to the center of the screen vertically. So let's also have a public void init position here for the bat, because it would be nice to move it into the starting position again and cut that from there and call init position, and then just paste that code that initializes the vertical position into there. And now if we go back to game.java, we need to make sure that if the game is won or lost, we reinitialize the positions. Let's give it a private void init object positions, and then we can just say ball.init position, player.init position, and opponent.init position. And this could be used. Well, we don't need to use it. We don't really need to use it in init because we're calling it in the init methods themselves. But we are going to have to call it if the game's won or lost. We want to reinitialize the position. So let's say that, or we could make it that before the game starts running, then we initialize the position. But it's probably simpler just to do it here. So if we lose the game, we need to reinitialize the positions of everything to avoid it getting into a circle of constantly thinking it's won or lost. So we just need to move the objects back to their starting positions after the game is lost or won. and I think we're there, hopefully. Let's take a look at the emulator. Sorry, not the emulator, the screencast. Okay, here we go. I tap the screen to start, and the screencast, yeah, it's catching up, which is good. And I'll bounce the ball once. And to make this an interesting game, this is going to have to be speeded up, but I'm just going to leave it here for debugging purposes. And let's lose the game deliberately. It says you lost, and then I can touch the screen and it starts again with the ball in the position, and so on. And sooner or later, if I wait long enough, the opponent will lose, which we've already seen happening, but that could be quite a while, so I won't bore you with waiting for it. But I think that all works, and so I'll leave it there. And you need to make sure, of course, stuff like if you go to the home screen of your phone and you go back to the game, you resume it, you need to make sure that it seems to behave nicely, which I think it does. It could always use more testing, but it seems okay, and make sure you can start it from the icon successfully and stuff like that. Okay, so that's it for this time, and in the next tutorial I think we're probably going to start looking at sound, which we may get through in one tutorial, but I'm not sure. So that's it for this time, and until next time, happy coding. Hello, this is John from caveofprogramming.com, and in this tutorial we're going to look at playing sounds. So I've got this game at the moment which bounces this ball around. It's a very, very simple game, and in order to make this at all playable, really we want it to make some sounds as the ball bounces around. So we're going to look in this tutorial at how to play a sound, and I just want to mention once again that it doesn't actually look this jerky in real life. It's just that the screencast, which I keep calling emulator by mistake, but the screencast of my phone only refreshes once every so often, which makes it look pretty horrible. So I'm just going to show you how to load one sound in this tutorial, and then we'll look at playing more sounds together in the next tutorial. And I'm going to use a class called Sound Pool. So in my game class, this is a logical place to load sounds because I'm already loading bitmaps in there, and I need some sounds to load, and I've created some sounds for my game. So I've got sounds for when the ball bounces, and I've got sounds for when the game is lost or won, and a sort of start sound which I might use as well. So I'm just going to copy those, and I'm going to go to Eclipse, and I'm going to create a folder for these. So I'll right click, in fact I'll create a folder in resource. I'll right click the resource folder, res folder, and go to new folder, and I'll just arbitrarily create a folder called raw and click finish. Or I could call it sounds or something like that, I suppose. I don't think there's any particular need to call it raw, but it's as good a name as any, because this is going to be kind of raw data. So I'll right click raw, and well, it's not really raw data, but anyway, I'll right click raw and I'll paste my sounds into there. And you can also just go to the folder on disk and copy them in, but if you do that, don't forget to right click and go to refresh to make them actually appear. And let's try to just play the start sound here. So in game here, I'm going to give this a private sound pool, and I'll call that sound pool with a lowercase s. And in the constructor of game, I will create a new sound pool. So let's say sound pool equals new sound pool. And the constructor takes a few different things. Let's just add the input there. It's just a random error from Eclipse. It's Control Shift O. Maybe the input's already in there now. And then I'll do Control Space. And here we've got a few arguments that we need to supply. So we need to supply the maximum number of sounds that we're going to play simultaneously. And in this game, I can't imagine it's going to be all that many. So let's just say 5. And it probably won't even be that many. And the stream type here, we can see should be set to soundpool.streamMusic for games. So it says down here, and I haven't explored any of the other types. Let's just use that. So I'll say sound pool, dot stream music. Maybe I'm wrong there actually, maybe it's not sample.stream_music. Let's just take a look. Yeah, it's audio manager.stream_music. So I'll say here audio manager.stream_music, stream music, there we go. And now the third argument here, it says is, I think it says it's not used, it's the source quality, which currently has no effect, and it says use 0. So we'll use 0 for future compatibility. So we've got our sound pool that can manage and play a pool of sounds, and now we can load a sound and play it. So let's go down here and, well actually maybe in init just for the moment I will play a kind of start sound. So let's say sound pool. This method is called when the game loads up, but I could put this in the constructor. I just want to show you here playing one sound. I'll say soundpool.load, and we need to pass in the context, and I think I have that here. Hopefully we have maybe I don't have the context here. How annoying. So let's pass it in to my game then, because I'm passing in resources and the surface holder, but at the moment not the context. So I'll go to my source code, and game is created in game view, and let's say that when we create the game we pass in the context, which I was kind of hoping to avoid, but it feels kind of messy, but fair enough. So here's my game constructor, and I'm just going to pass in this for the context, and the context is an interface that the activity implements. And then I'll go to game, click on it and press F3, and in here we can say context, and I can have a private variable to store that context. So private context, and I mustn't forget to set it down here. So this dot context equals context, and I'll just do Ctrl+Shift+O to add the import for context. And now we've got it in a private variable and it's passed into the constructor. I can go ahead and use it down here. So I can say soundpool.load context. Resource ID is of course the ID of the sound we want to load, and I put those in. I put the sounds as MP3 files in a folder called raw. So I'm going to say here r.raw. And let's try this start sound here. And the priority I think is not used, but let's just check. So if I just delete that and do Control space, maybe delete the bracket, and hopefully we can bring up, well there's no, I'm trying to bring up the help, but maybe if I hover over load here, and no, that's not working either. Let's try typing 0 and now hover over load, and there we go. And if I move into here and scroll down, whoops, let's try that again. I'm pretty sure that the last variable is not used, so priority. The priority of the sound currently has no effect, use 1 for future compatibility. So let's just put 1 for this last argument there. And now finally we can go ahead and play it, and we need to make sure that the sounds are loaded before we actually play them. And normally probably what I'll do is not kind of worry about it, because I think if you try to play a sound that's not loaded, I don't think you get an error or anything, but we'll kind of look into that later. But since here I want to just type something below this line that will play the sound, I am going to have to load it, because this is going to return immediately, but it's not going to be loaded until some time later. So to get around that, we can say sound pool dot add or set on load listener, on load complete listener, and here we can have a new on load complete listener. And let's just use the kind of anonymous method syntax here to implement the onLoadComplete method of this interface. And I'll just do Ctrl+Shift+O to add that. And we need media.sample.onLoadCompleteListener. I think that's the one. And now this will be called when a sound is loaded. And we know what sound it is because load here actually returns an ID. If we take a look at this, we can say that it says it returns a sound ID, and this value can be used to play or unload the sound. So I'm going to go up here and I'm going to say int start sound ID equals soundpool.load, and then this ID is going to be passed in as sample ID here. So if I just want to make sure that I'm playing the start sound, even though in onload, even though actually at the moment I'm only loading one sound, I could say on if start sound ID equals sample ID, then I know I've got the start sound rather than some other sound that I could also have loaded down here. And oh yeah, I need to make this final in order to be able to access it in this anonymous method. And now let's finally play it. So I'll say soundpool.play, and I need the sound ID, which is going to be start sound ID, of course, and the volume, which is between 0 and 1. Let's just check that. Let's go to the documentation. So the volume is, where are we? Let's take a look. The volume is 0 to 1.0, and in the next tutorial I'm going to show you how you can make that respond to kind of the volume level that the user sets. But for a moment I'm going to hard code it, and we're going to have priority of 1, and loop is going to be 0 for no loop, and rate is going to be 1 for normal playback. So we're going to have 1, 1, priority 1, loop 0, and rate 1. I think that's correct. Let's just take another look. So sound ID, the volume 1, so I'm going to play at a maximum volume just for demo purposes. Priority of 1, and to make it play, I want it to play as soon as I tell it to play, rather than kind of dallying about. Loop is going to be 0 because I don't want it looped, and rate is going to be 1 for normal playback. So let's try that, and if I've got this right, when I start my game up now, we should hear a sound. So let's see, and well, we've got some errors here, I'm not sure where. Let's take a look at game view, and the constructor is undefined. Did I change the constructor properly? So we've got a context there, and in here it's saying, oh yeah, I need to say not this because we're in the view class. I need to say get context, and that should do the trick. So we're in the view, and to get the context, the activity, I can say get context. Okay, let's run that and see if that works, and hopefully we'll hear a sound. So usually I often cut bits out of my video when we're just waiting for something to load, but I won't do that this time because we're going to hear the sound as soon as it starts, and I want you to be able to hear it, so bear with me. Let's take a look at the console. Where are we? The console here, Android. So it's installing, and in the next tutorial we're going to look at playing multiple sounds, and there we go, that's my start sound, which I must admit is perhaps a strange choice of a start sound, but I'll let you fiddle about with that to your heart's content. So that's how we play a single sound, and in the next tutorial we'll look at playing multiple sounds, and we'll look at adjusting the volume either in the next tutorial or the one after, using the volume button on the side of the phone. So that's it for this time, and just a reminder, I created this sound using something called Cycle, which I think I still have open down here, or maybe not, but it's if you look for Cycle Modular Music Creator, it's a tool that you can use to create both sound effects and also actual music for free. So it's really handy for this sort of thing. And I adjusted the volume and trimmed the sound in Audacity, which is another free music editor. So that's it for this time, and until next time, happy coding. Hello, this is John from caveofprogramming.com, and in this tutorial we're going to look at playing multiple sounds in Android. So at the moment we can play one sound, but of course I'd like to be able to play lots of sounds in my game. And to do that, it's pretty simple, and if you follow the last tutorial you can probably already guess how to do it. In game at the moment I'm loading a kind of startup sound and I'm playing it as soon as it's loaded, and when we load a sound we get an ID of the sound. So the first step is to load all the sounds that I want to use and to get IDs back from them, and the init method of my game I think is as good a place to do that as any. But now I need some way of storing the IDs of these sounds and being able to refer to them later. And the ideal thing for this would be to use a map. But the only problem with a map is that if you've got a lot of sounds, you don't really want to be looking things up in a map in order to play a sound, because conceivably that could introduce a delay. Although I think in practice it's quite unlikely that anyone's ever going to notice a delay unless you've got a game with thousands of sounds in it. But nevertheless, let's try to do something a little bit faster than looking up a sound in a map. So what I'll do is I'll first create let's maybe have a abstract class here. So I'll create a class called sounds, and I don't want to instantiate this class, so I'll make it abstract. I'll say public abstract class, and this is going to be purely a place where I can hold some constants. So I'm going to say public final static int start equals 0, and I'm going to use these values as an index into an array where I'll store the actual IDs of each sound. So this is going to be a kind of mnemonic to enable us to remember the kind of sound that we're looking for. So let's just copy that, and I'm going to have start, win, lose, and bounce 1 and bounce 2. So let's have start, win, lose, bounce 1, and this is going to be the sound that the ball makes when it hits the bat, and bounce 2. I'm just going to set these to consecutive values, and this is a little bit hacky really, and we should use a map, but as I say, for the sake of speed I'm going to just do it this way. So 0, 1, 2, 3, 4. And now in my game I'm going to have an array. So let's say private int sounds, and that's going to be an array of integers. Let's say int array. I've got a little problem with my typing a right hand bracket in Eclipse because it conflicts with some kind of shortcut, I think. Let's say private int array sounds equals new int array, and I'll make this I'll make this an array of 5 integers. And now what I can do is I can go to the point where I loaded one sound and I can load all of them. So instead of saying final int start sound ID here, I'm going to say sounds and start. So what I'm doing is I've used my constant, which is I started these constants numbering at 0 and then going consecutively, and actually I need to say sounds.start, and I'm then using those as the index into my array. And the idea is then if I want to look up a sound using, for example, sounds.start, it's going to be very fast to go immediately to the correct ID of that sound, which soundpool.load returns in that array, rather than using a map to store the kind of name of the sound versus the ID of it, which would be a tiny bit slower. So I'll just copy this, and we need 1, 2, 3, 4, 5, and I'm going to have sounds.start and 1, win, lose, bounce 1, and bounce 2. And now I need to fill in the resource IDs here. So I've got r.raw.win r.raw.lose and bounce 1 and bounce 2. And in this load thing here, this init method seems as good a place as any to play the startup sound. So I just need to make sure that I'm looking at if sample ID equals this start sound, then I'll play it here. And to get the idea of it, I look it up in that array like that. Or I could just actually use the, it will make more sense really, just use the sample ID that's passed in to this method. So this array is just storing the sample IDs of each sample. So now I should be able to play any sound when I feel like it. And for the rest of the sounds, I'm just going to call sound.play at the right moment. And I won't worry about checking that they're loaded because it doesn't seem to give an error if it's not loaded, as far as I can see. But if you want to look into that further, be my guest. But I think I'm content just to call play and hope that it works because it seems to be all right. So let's copy this, and I could put in a kind of lost sound here. So if they've lost, we'll go to case.lost. In fact, that isn't a good place to put it at all because that's the draw method. Let me get rid of that. Let's look for a sensible place to put this. So in update game, at this point, this just gets called once. I switch the state to lost, and then it's in the state lost, and update game will only be called if the state's running. So this seems like a good place to play the lost sound. Let's put it in here. And the sample ID is going to be sounds, and the class name sounds.lose. And let's put the win sound in as well. So I change the state to 1 here, and this is where I play the win sound. And then the really interesting bits are the bounce sounds for when the ball hits the bat. And somewhere in here we've got some code that detects that the ball has hit the bat, and that happens in update game, I should think, if I remember rightly. Let's take a look in update game. So here we're saying that if the ball is if the kind of left hand bat hits the ball, then we tell the ball to start moving right. And I might have to, if I find that this is going to play double sounds, like this, it may be that this is called multiple times really quickly, one after the other. We'll check and see if that is the case, and if so, I need to put in a little bit of code to stop that happening. But let's just try this, and let's say bounce 1, and similarly here I'm going to say play bounce 2. Now let's see how that works, and I'll click run, and with a bit of luck it'll work right out of the box. And if not, what I'm going to do is I'm going to check here and say if the ball is moving, I could do something like if the ball is moving left, then make it move right and play the sound, and maybe that would ensure that I can only play one sound. But let's, rather than speculate, let's just see how it works in practice. Okay, so my game's running now, and I should be able to go to the screencast, and let's click start, and it hit the bat, and that actually seems to work pretty well. It's not the best bounce sound in the world, and it has actually got a sort of bass aspect to it, but that the kind of bass aspect is sort of dwarfed by the white noise that I've added, and both the sounds actually sound different, but playing on the phone you can't really tell. So I could have chosen better sounds, but that's not the point here, and you can see that it works. And let's just lose, and we should hear the lose sound. So I'll move the bat out of the way. There we go, you lost. And we could play the start sound when you start playing again actually, but anyway, that's enough for this tutorial, and in the next tutorial we're going to look at changing the volume in response to the user changing the volume using the button on the side of the phone, which would be quite handy rather than playing it at maximum volume all the time. So until next time, happy coding. Hello, this is John from caveofprogramming.com, and in this tutorial we're going to look at controlling the sound using the buttons on your phone or your device. And that turns out to be very simple. We just need to add one line here. And first I'm going to go to my game.java and I'm going to look at where I create the sound pool. And here we're telling it to play using the audio manager.stream music flag. So keeping that in mind, I'm going to go to game view. Actually no, I'm not. I'm going to go to my activity, main activity, and I'm going to specify that this activity will control that sound stream. And to do that I use a method of the activity which I'll call it onCreate. And I'm going to say here set volume control stream and pass in that same flag, which is audio manager dot stream music, which is down here. And now I'm going to run the game, and what we should see is that the volume control controls the kind of media volume, which will control the sounds in my game. And I actually was previously doing this using a method that was a lot more difficult and involved changing the volume when you actually play the sounds. So here you can specify, when you play a sound, you can specify a volume. And I'd seen techniques on the internet for figuring out this volume based on the volume control. And it didn't work well at all, because you could only control the volume of the sounds when they were actually playing. And then I looked at the Android documentation and discovered I'd been doing it the wrong way. And this way is a hell of a lot easier. So let's just go to the screencast. Here we go. And I'll tap the screen to start. And now if I use the volume control, you can see that I've got the volume set to maximum at the moment, and it's controlling the media volume rather than the ringtone volume, let's say. And if I now, let's lose the game. So that's maximum volume. But if I now turn the volume down, you can hear that the ball's getting quieter. And let's lose again, if possible. I don't know if you can hear that, but it's much quieter. So now we can control the volume of the game. And that's it for this tutorial, and that's all for this little section of the tutorial on programming games. And of course this is a very, very minimal game, and there's so much you could do to improve this, like adding a score to it or just turning it into a different game. But my object here was just to show you the basics of animation and sound. And if you get really serious about games, you might want to take a look at And Engine, but I warn you, it's a bit of a pain to install and the documentation is kind of sparse. So for my money, writing games like this from using kind of from scratch, so to speak, isn't such a bad thing to do. Okay, so until next time, happy coding. Hello, this is John from caveofprogramming.com, and in this tutorial I'm going to walk you through installing Google Play services, which is like the first step in getting a version 2 map application running. And this latest version of the map SDK is as new to me as it is to you. But I thought, so I have no kind of special expertise, but I thought I'd just to include this for the sake of completeness in these tutorials, I thought I'd kind of go through the basic steps that you need to get a map application working, at least. And if nothing else, maybe it'll give you some faith that it can be done, because I have to say this has had me pulling my hair out, and it hasn't been easy. But if you pay close attention to the instructions on the Android developer page, then it certainly usually does in the end work. So at the moment it's February 2013, and the version 1 of the map SDK, which I originally included in this series of tutorials, has been deprecated. And from March 2013 we're using version 2 of the Android Map SDK, which is not to be confused with the JavaScript SDK. The JavaScript SDK is going from version 2 to version 3. So the instructions that I'm going to go through, they may well change, and I'd strongly advise you to look at the developer documentation. And I'm kind of making this with the kind of sinking feeling that this could easily be obsolete, the stuff that I'm about to tell you, in a matter of months, who knows. But if that should be the case, then I'm just kind of hoping this is some use to you, and just in going through the basic stages. But I would advise you to look at the documentation. So if you type into Google something like Android V2 map tutorial or something like that, and of course this assumes that we're still on version 2 by the time you're looking at this, and we haven't moved on to version 3 or something like that. Make sure you have Android in there though, because you don't want instructions for the JavaScript SDK. And go to this page from developer.google.com, and here we find the instructions that you need to go through. So these are the steps, and basically you need to install Google Play Services, which now encompasses the Map SDK. You need to get an API key. You need to create like a library project that will include the jars from Google Play Services. That should be step 2 really. And then you need to put together your demo application, and off you go. Hopefully it will work. So let's cover in this tutorial just installing Play Services and creating the library project which you need. And to do that, go to Eclipse and go to, depending on your version, but for this version it's under Window, go to the SDK Manager, and then you need to scroll down to the bottom, to the Extras section here. Down here at the bottom is Extras, and make sure you tick Google Play Services here, and if it's not installed then tick it and install it here. And that when I did it, that actually took several hours. I think it was quite a slow job. And once you've got that, you need to find the library project that installs. So I'm on Windows, so if I go to C, and these instructions are all included in that developer page, so I'm just telling you stuff that I've literally learned myself from that page not long ago. So I go to C, Users, John in my case, Android-SDKs, Extras, Google, and then you see this Google Play Services folder, and if you go into there and then click lib project, you see this Google Play Services lib, and that's what you need. So you need to create a lib project like this in your workspace, and to do that, at least the way that worked for me was, well actually first I'll copy that path, so I'll just click up here and do Control C, so I've got it copied, and I'll go into Eclipse and go to File, Import, Existing Android Code into Workspace under this Android folder here, and click Next. And for root directory I'm going to just paste in that lib project directory, and I don't know why that's not working. Let's try clicking Browse and OK. That seems to make it happy. So then I tick Google Play Services lib and I click Finish. I think that's all I had to do. So now we've got this project here. If I expand that, we should see some jars and stuff in it. There's Android.jar and probably some other stuff, Google Play Services jar. And if I right click and go to Properties and Android here, we'll see is library should be ticked here as well. So I haven't had to do that, it's just been ticked automatically. So I think I'll leave it there for this tutorial, and in the next tutorial probably we'll look at getting an API key and creating a basic project or something like that. Okay, so that's it for this time, and until next time, happy coding. Hello, this is John from caveofprogramming.com, and in this tutorial we're going to look at creating a basic map application. Well, we're not going to see the maps working yet, but I'm going to get as far as registering the debug key with Google, which is something we need to do before we can get this thing working. So I've got my Google Play Services lib library project set up from the last tutorial, and I'm going to create a new project here. So I'll go to File, New Android Application Project, and I'm going to test this project on my phone, which is a HTC Desire C running Android 4. But you can run this in an emulator as well, and I'd suggest at least the first time you do this, it's probably best just to choose a really recent version of Android. Don't complicate things any more by trying to get this working with an old version, because I have found this a bit of a nightmare to get working initially, and I don't know why, so it's probably best to take the simplest route the first time. So now, if I remember what I did last time correctly, I think I set the minimum SDK version here to Android 4, and target SDK, I think I'm going to set that to Android 4 as well, and compile with, I don't remember what I set it to. Let's try Google APIs 16. I think that should do the trick. I'm not sure if this is really crucial, but because I've only done this once before and successfully got it working, but I'm going to try Google APIs 16, I think, to start with. And the application name, let's call this map test or something like that. And you need to put it in a package, of course. So I'm going to put it in com.caveofprogramming.android.maptest, but choose something else. Make something up if you don't have a website. It doesn't matter as long as it's unique. And then I click next and just go through all this. Click finish. And now we need to tell this project to use this Google Play Services lib project. And to do that, I right click the project and go to Properties, Android up here, and is library should not be ticked, so don't tick that. But underneath that you see this table, blank table, and I need to click Add here and select the Google Play Services lib project. Click OK, and then OK. So now this project will use the jars from that library project, and now we can go ahead and get an API key for this. So if you want to release an application, you need to go through the whole business of signing your application, and you'll need to register the release key with Google. And for the purposes of getting this running, I'm going to register the debug key with Google. But when you want to release it and to actually upload it, you're going to have to do this with the release key that you need to create to publish applications, as we've seen previously. But apart from that, it's going to be the same as it's going to be similar to what I'm about to show you. So let's dig up the relevant documentation here. So I just searched, this is from the last tutorial still, for Android v2 map tutorial, and went to the first link on developers.google.com, and I get this page, and it's got this stuff about displaying certificate information, and we need to kind of do all that stuff here. So what I'm gonna do is signing in debug mode here, and you need to deal with this Google APIs console. So let's open that, and I'm sure if you just type in Google APIs console into Google, you'll get a link to this pretty quickly. And in fact, I'm signed in as the wrong user here, so I'm just going to sign out and sign in again. In fact, I'll pause recording for a second. So I've signed in using my free Gmail account to Google, and now if I search for Google API Console here and go to this API Console, I need to make sure that I'm signed up for the Android Map API service. So if I go to services here are a bunch of different services, and somewhere down here you'll find Google Maps API v2. That's not the one you want. The one you want is Google Maps Android API v2, and you'll notice there's not any so-called courtesy limit. You can use it unlimited usage without paying anything. So make sure you get the Google Maps Android API version 2 and make sure that's turned on here. And then the next step is, if I remember this rightly, and again this is just instructions from the developers.android.google.com, whatever it is. It's instructions from the standard Google documentation that I'm following. But I think I need to create a API project. So if I go, here's the console kind of route, and if I go to click this thing at the top, and this may have changed by the time you're looking at this. So this is, please just take this as a kind of example of what you might have to do. I'm going to click create to create a API project. Let's call this map test. Click create project. And in fact, yeah, maybe I already did that. I'm not completely sure, but let's turn on Google Maps Android 2. And now, the important bit is that I need to get the key that enables me to use the Map API. So if I click on API access here, this is the bit that we need to get to. And you'll see down here it says create new Android key. I'm going to click that, and here you've got some instructions for creating a key. So this is where if you're releasing your application, you're going to publish it, you need to find your release key, and you need to register that key here to get basically to get a key that you paste into your application. But I'm going to register the debug key to get this running in debug mode, and to do that I'm going to start a new command prompt. So you can do that by clicking on your start menu, typing cmd and just going to cmd.exe there, and then I'm going to go cd ... actually no, I won't. I'll go to cd. So by default I've opened in my users directory here, and I'm going to cd to change directory to .android. I think that's right. Hit return and do dir to list the directory contents. And here we see debug.keystore. It's in my user folder in the .android folder, which may be hidden if you view it in Explorer, I'm not sure, but here we can see it. And this debug.keystore contains a key with the password Android in it, and I'm going to try to register that. So you need to make sure you've got access to the key tool, which is part of Java. So I should be able to type key tool here, hit return, and I should see a load of gumph like this. If you don't see that, you need to type the full path to key tool. So you could just search for key tool in your start menu if you don't see it, and just right click it and go to properties, and then type this full path here. I'll just copy that and paste it in here, and then add /key tool, and again you should have the same results. Well, actually I need to put that in double quotes because there's a space in program files there. Let's try that. There we go. So same results again. So you only need to use the full path to it if it's not in your path environment variable, and if it isn't, then when you type key tool you won't see anything. It'll say command not found or something like that. So once you've located key tool, you can paste in this stuff here. Let's just copy it, just this first bit here, because this is the name of the key store, and I'm going to have to specify that manually. And so I go to my command prompt, paste it in, and then I need to type in debug. Well, I just typed in DE and hit return, hit tab, sorry, which auto completed. I hit return and it asked me for the key store password, and for the debug key store the password is Android, so I type Android and it gives me all this stuff. And now I'm going to click up in the corner here. Of course this is going to be different if you're using a Mac or something, but I'm going to click up in the corner and go to edit, mark, and then start selecting. I'm looking for this SHA1 thing here, and I'll start by selecting the first digit here, go right to the end there. Just make sure you select exactly all these hexadecimal digits separated by colons, and then press return, and that copies it to the clipboard. And I can now go back to this and paste this in. And if you read here, we also need the package name. We need to follow that by a semicolon and then the package name of the application. So let's go to Eclipse and expand source here and go to main activity. And at the top here we've got this package. I'm going to copy that, Control C, go back to the browser, and now type a semicolon at the end of this long string of digits. A semicolon, not a colon. So these are colons. You need the semicolon, like at the end of a line in Java, and then paste in the package name. So this is, I'm just following the instructions here, basically. And then I click create. And if everything's right, we're going to get this. We're going to get a key for Android apps. Now I need to paste that into the right place in my application, and the instructions for doing that are in this documentation here, the map v2 tutorial. So if I scroll down here, and it's going through all the stuff that I've just gone through, creating an API project and all that kind of stuff. And then if we look down, this is how you actually add it to your application. So we need to add something into the manifest. So I'm going to just copy that, and it says add the following element as a child of the application element. So let's go back to Eclipse. This is horribly complicated, but if you have the patience, it's not rocket science. It's just annoyingly fiddly. So we go to the Android manifest XML. Let's click on the XML tab, and in this application element here, within this, I need to paste in that. Let's just double check that that's right. Yeah, it actually says by inserting it just before the closing tag of application. So I don't know if it makes a difference, probably not, but let's put it in the right place, just before the closing application tag. Then I go back to my browser and go back to the API console and copy this API key that we've created, and I paste that in here where it says your API key. Make sure you get the whole thing, and I'll just do Control-Shift-F to format that and save it. So now we've got a registered debug key in the application, and we're close to getting a map application working, although I'm laughing because last time I did this it just didn't work, and the time before it didn't work either. But after redoing it several times, it started working. I don't really know why. So okay, so that's it for this tutorial, and in the next tutorial I'm just going to paste in a bit of code and some permissions, and we'll see if this works or not, and if it doesn't, then I'm going to go and pull my hair out. Okay, so until next time, happy coding. Hello, this is John from caveofprogramming.com, and in this tutorial I'm going to see if I can now take my map application that I've been setting up and get it to actually display a map. And I don't hold out a huge amount of faith, but if it doesn't work in this tutorial, I'll go away and fix it, and hopefully we'll get it to work. So I've got my application now, and it's got the right library project included in it, so it's referencing this library project, and I've registered my debug API key, and now it should just be a question of pasting some stuff in from the tutorial basically. So I searched for, as you've seen in the previous tutorials, something like Android v2 map tutorial, and we get this page. And now, so we've added the API key to the application, and we need to specify some permissions and stuff like that. So if you don't add this stuff, actually the debug output is pretty good at warning you. The thing where it's easy to go wrong, I find, is that if you haven't registered the key properly or something like that somehow, then it just sort of fails silently. But all this stuff is usually fairly unproblematic. So we've added this bit here, and we need to add these permissions together with the right package, which will be the package name that we specified to register the API key. So let's just copy this, and I'll go to Eclipse, which has now decided to stop working. Here we go. Maybe not. Okay, maybe it's hiding behind my. There we go. Right. So let's go to the manifest here, and I'm going to paste at the same level as this uses SDK here. I'm going to paste in this permission thing, and I need this this package here, which in my case is com.caveofprogramming.android.maptest, and that's going to match whatever you have in your main activity here. It's this stuff here, this package name, and I'm going to paste that where it says com.example.mapdemo in the stuff that I just pasted in. So let's paste it there. So now we've got com.caveofprogramming.android.maptest, which is my particular package, and yours should be different. .permission.maps_receive. Save that, and we'll go back to the tutorial and see what else it says. So we've got another bunch of permissions down here that are to do with, you perhaps don't necessarily need all of them, but I definitely recommend copying all of them in the first time you do this, because it's an achievement getting this stuff working, you know. So let's copy all those, paste all those in. Maybe I can, there we go, get to Eclipse, paste them in here. I'll do Ctrl-Shift-F to tidy that up a bit. And we've also got to put in something that has something to do with OpenGL, if I remember correctly. So I'm having trouble switching between screens. Here we go. So yeah, so here we go. So we've also got to paste in this thing here, this uses feature thing. And if you don't paste that in, you get actually a nice warning in your debug output. If you look very carefully through the debug output, you'll actually see that it's complaining if that's missing. Let's paste that in. So I go to Eclipse and paste that in there. Ctrl-Shift-F to format it. And we're almost done. And now we can actually add a map. So I'm going to copy this fragment, this XML fragment here, and that can just be pasted in verbatim if that's the word I want. So we go to activity main.xml under layout here, paste this in, So instead of that, I'm just going to delete the stuff that's in it and paste in that fragment there, save it. And then finally, I think we can go to, we can paste in this source code in mainActivity.java. I'm not sure actually whether this is really necessary because it looks like what's already there, but I'm going to copy everything below the package name because we have to leave the package name at what it already is. So I'm just going to copy the stuff below that and go to Eclipse and go to source and then mainActivity.java. And again, just highlighting everything below the package name, I'll delete it and paste in the code from Google. I've got an error because their XML is called main.xml and mine's activity_main, so I'm just going to delete that and just do control space so we can get the right layout here. And I'll probably get some error from Eclipse because it does that recently, but then we want to just select the layout that we pasted the fragment into and then save all that. Now, just to be on the safe side here, I'm going to go to Project Clean and click OK to clean my project and build it from scratch. And having done that, I'm going to click the Run button. And if you're superstitious and you have anything that you do for good luck, then now's the time to do it. Let's click OK. And I've got a screen, what do you call it? Not an emulator, a screencast thing here somewhere. If only I could bring it up. Let's try to locate it. Okay, so well, I can see that my phone is opened. Let me start the screencast, and actually I've been successful, which is great. It's almost like the more times you do this, the more cooperative it gets, and I'm sure it's that this is the third time I've done this now. I'm sure it's that the other times I was missing out crucial steps, but I had to keep, I was repeatedly cleaning my application in Eclipse, doing a clean build, uninstalling it from my phone, and doing all kinds of stuff to get this to work. And eventually, just when I was virtually thinking of giving up and deciding that I was going to have to leave Maps version 2 out of this tutorial, finally it just magically worked. So it's worth persisting, but you have to get everything right in the steps that we've just followed. Every single step has to be correct, and if at the end you get a blank map, like a blank grey map, it's almost certainly going to be because your API key is not registered correctly. So it may be that you're deploying the application somehow without having rebuilt it fully or something. Try uninstalling it on your phone. Make sure you've registered the API key with the correct package name and everything in the Google API console thingamajig, and make sure you've done a clean build and uninstall the previous one from your phone if there's a previous one and deploy it, and eventually it usually does work. And people say on the internet that if you see that blank, oh yeah, and also make sure your phone's connected to the internet. That's an important one as well, because if it isn't, you probably are going to see like a blank grey application. Okay, so that's it for this tutorial, and until next time, happy coding. Hello, this is John from caveofprogramming.com. In this tutorial we're going to look at adding markers to maps. Now the thing is, I've done this before in Android Map version 1 API, but I've never done it with this Map API. So what I'm about to show you is just me looking stuff up and trying to get it to work. And I'm just putting this in to this Android tutorial because I wanted to show you something that isn't just the absolute basic map stuff, but equally this is a new API to me, just as it probably is to you, and I don't know my way around it. So I'm gonna try to get this working in this tutorial by following the documentation, and if you want to see an example of this working in front of you, then hopefully I can sort that out for you now. So let's go to a internet browser, and actually here is the map application I have at the minute. It's just the basic demo from the Google Developer Guide. And into Google I'm going to type something like Android map v2, because it's no good using the v1 at this point, and something like add map marker or add marker. Whenever I want to find out how to do something, I just type it into Google like this using keywords, appropriate keywords. And with Android stuff, the developer documentation is usually the best place to look. But with other programming stuff, then of course often you can find lots of examples elsewhere. But there's one central point for Android here. So it looks pretty simple. It looks like having we've got a map fragment that's displaying, and it looks like we just basically have to get that fragment and add a thing called a marker to it. Like it's like a hello world marker they've got here. I literally have just seen this document for the first time 10 minutes ago, so I don't know what I'm doing here, but I'm going to try doing this. So we've got to get the map and add a marker to it, and this is quite a lot simpler than the version 1 API, which involved messing around with overlays and overlay items, and I think there was some other layer in there as well. Let's go to maybe the main activity here, and there seems to be something wrong. What I'm going to do is I'm going to restart Eclipse, and I'm going to pause recording of this video for a second. Okay, I'm back. I've just restarted Eclipse, and it seems to fix those weird problems that were coming up. Let's paste that source code in here, and I don't see any reason why for this particular application, just for this little demo, I don't need the map in a private variable. So let's just say here Google Map and get rid of this private declaration. I'll add the imports with Control-Shift-O, and that all looks fine. Let's run this and just see what it does. And if it works, I might try adding a slightly more interesting marker. So I'll run this on my HTC, and it looks like you can add these markers, and this marker options thing, from what I can see of the documentation, lets you set an icon and stuff like that on it if you want to. So let's try this. In fact, I see how they've done that. They're actually chaining methods here. So marker options has a position method and a title method. Don't think I've ever seen anyone do anything quite like this in Java before, but fair enough. We could rewrite this by saying marker options marker equals new marker options, and then we could set stuff on it, like we could say marker. I'm going to show you the running program in just a second, but we could say marker dot position, I zoom marker dot position, and set 0, 0 and marker dot title 0, 0. I assume that would work. Oh, not 0, that should be hello world or something like that. Oh yeah, and the position should be new lat long. This is a new class on me as well. I haven't seen this before, so they've changed quite a lot since the last time. And if these are set methods, which, yeah, let's hover the mouse over position, press F2, go into this documentation. It just says sets the location for the marker. So now we could supply the marker to here like that. And to my mind, okay, that's a bit more verbose, but it looks easier to tell. It's easier to tell what's going on. Okay, so now what we've got is this, and we've got a marker there on the map. And if I pick up my phone here in the real world, I can zoom in on that marker. There we go. Now, if you look at the documentation, there's lots of other stuff you can do, like you can get stuff that's displayed, you can add stuff, a snippet that's displayed below the title, like you could in the previous version. You can make it draggable, which is very nice, and you can set an icon as well, which I guess is just a matter of putting an image, I presume, in your in like a drawable folder, and then just specifying the ID to the marker, I should imagine, but I'm not sure. I haven't tried it. and we've got some more examples down here, like setting a position at Melbourne. This is a longitude and latitude. And what else do we have? Yeah, and here we've got an example of setting an icon. It's a bit more complicated than I imagine. So we've got to call the .icon method, and we need to use bitmap descriptor factory dot here it says .default marker. So there's a bunch of default markers that we can set as well, apparently, if we just copy and paste that. So I'll leave you to play around this. It looks pretty nice, actually. I have no real desire to add markers to maps myself at the moment, but it could be very useful. And also, as in the last API, it looks like we can also add a on-marker click listener to a marker. Let's just do that actually to finish off this tutorial. I'll try one other little thing. In fact, let's try a couple of little things from this document, because it'd be interesting to have a different bitmap really. So let's set the icon using this. So I'll call the .icon method a marker, which is marker dot icon, like that. Now, does that work if we add the import for bitmap descriptor factory, add the semicolon at the end? So this should give us an Azure marker. I don't know what other options we can have. And let's set the snippet to something. Then maybe we can set a snippet, and I'll leave the longitude and latitude where it is, but I will set the title as well. So let's say marker, I've set the title to Hello World actually already. Let's say marker dot snippet, and some info goes here. And finally, let's see if we can figure out when the user's clicking the marker. I presume we can detect drag events on it as well. Yeah, marker drag events. So I think this is a considerable simplification of the previous API by the looks of it. Let's see if we can add one of these click listeners, like marker dot on, or maybe set click. No, maybe not. I'm going to have to consult the documentation clearly. So there's no set on click method. Let's take a look and see what it says. So you can use it on info window click listener to listen to click events on an info window. I don't think we need to do that. I need to look at these marker click events. You can use it on marker click listener to listen for click events on the marker. Oh, so we need to say Google Map.set on marker click listener. Fair enough. Well, let's try that then. When a user clicks on a marker, on marker click marker will be called. All right, let's try this. So Google Map.set. So I presumably I need to get my map here. Map.set on marker click listener. New on marker click listener, I presume. And let's add the semicolon, add the imports there, Control-Shift-O. And finally, so yeah, the actual marker in question apparently gets passed in. And let's just pop up a toast. So let's say toast.make text. Context is going to be the activity, but I can't just say this because we're in a method of an anonymous class. So I need to say main activity dot this. The text, let's display marker dot, can we say get snippet? Yeah, let's try that. And the duration, I'm going to say toast dot length long dot, and now I need to say dot show to actually show the toast. So let's run that and see if that works, and then I'll leave it there, because as you can see, all I'm really doing is looking at the documentation, which is probably a limited value to you, but I just wanted to put something extra in about maps. And while I'm waiting for that, I'm going to just pause the recording for a minute. Okay, it seems to be running, and there's the marker, so I'm going to go to my phone. Let's zoom in a bit actually, and let's just click the marker. It's in the middle of the ocean. And there we go, we've got a toast popping up. So I'm quite impressed with that actually. I think it's a lot better than the previous map API, I must admit. That's it for this tutorial, and until next time, Happy coding.